In this lesson, we'll talk about polynomials and special products. So first off, a polynomial is simply an algebraic expression where we have terms that are either numbers or numbers multiplied by variables with positive integer exponents. So the key here is that you can't have negative exponents, you can't have fraction exponents, and so on. So we have the coefficient of a term, which is the number part of any term, as we had in the previous lessons. And if you have variables, now sometimes you have more than one variable in one term. If you add the exponents, we call that the degree of the term. Now most of the time in this lesson, we will have only one variable per term. Usually the whole polynomial will just be in x. So anyway, if a term has only a number, so say this 3 here, we say this is a degree 0 term. Because technically we could have an x to the 0 hiding, and it would just disappear because x to the 0 is 1. And then finally, when we're talking about a polynomial in general, the degree of the polynomial is the highest degree among all the different terms. So then we've got some other terms here. We've got monomials, which consist of one term in the polynomial. 2 terms are called binomials, and 3 terms are called trinomials. Now we'll just use these terms in practice, so you just want to make sure that when you hear them, you know what they mean. So, for example, these 2 expressions are not polynomials, so our goal is to figure out why. And it's pretty simple here. For the first one, you cannot have a negative exponent, so no negative exponents. Negative exponents are not part of polynomials. Alright, and then for b, technically this here is x to the 1/2. So you can't have any square roots or fraction exponents in general. Alright, so let's practice this just a little bit. So we've got 3 polynomials, and we want to classify by the number of terms and label some of the coefficients and the degrees and the degree of the polynomial. So first off, this polynomial has one term. That makes it a monomial. Coefficients, well, there's only one. The coefficient is 6. And the degree of both the polynomial and the one term is the power 5. So the degree is always the power of the term, or possibly the sum of the powers if there are multiple variables. But for our practices, we won't deal with multiple variables. Alright, this one has 3 terms, so it is a trinomial. The degrees, in order, are 3. This one doesn't have a degree, but unwritten it's 1. And again, every constant term has degree 0. So then the coefficients are 1, unwritten coefficient here, -3, and the last coefficient is also a 1. And degree of the polynomial in general is the highest power, 3. Last one. This one has 2 terms, so it's a binomial. And then its degrees of each individual term, well, the x is technically an x to the 1, and the constant term has a degree of 0. Its coefficients are, well, this one's actually a -1, even though it's not written. And the 3 is the next coefficient. Finally, the degree of the polynomial is the highest power, which is 1. Alright, so here's the more standard polynomial that we're going to deal with. Now this looks kind of crazy, but it's not as bad as it looks. So this is a polynomial in one variable, specifically the variable x, and this is the degree n polynomial. So that simply means the highest power is the nth power, which means that this coefficient cannot be 0. That's where you see this an does not equal 0, because if it was, then it wouldn't have degree n. There would be no term here. So, this polynomial, this general form just simply is saying we've got some coefficient times a power of x plus another coefficient times a smaller power of x, and we go all the way down to just something with 1x and something with a constant. Now, you can have as many or as few terms, just this value can't be 0, so we have something to call the degree. Again, we call these things coefficients, and n is the highest power, so again that matches with the term degree. And then finally, we call this constant in front the leading coefficient. It's the coefficient of the highest powered term. And then finally, one thing to note is the powers are going smaller and smaller as we go across, so we call that descending order. Let's continue. So we've got this operation between polynomials. So it turns out that we can do polynomial addition, subtraction, multiplication, and division. And so to do that, all we really do is combine like terms. So for addition, I'm just going to drop my parentheses immediately. They don't really have any additional purpose. And we'll just combine everything that is alike. Let's see, x squared y, we don't have another term like that. But we do have a xy squared, which is different from x squared y. The xy's actually add out. We've got a negative and a positive. We've got a negative 6y and a positive 6x. So all we did there really was just combine like terms. Next one. This one has subtraction. And again, I'm going to drop the parentheses, but I'm going to do it kind of carefully. The first part, I can just remove the parentheses. But the second part, what I'm going to do is distribute my negative sign. So I get negative 4 plus 6x plus 3x squared. And now that I don't have parentheses, I can just combine like terms. So I get 5x squared plus 3x squared is 8x squared. Negative 6x plus 6x, well, those cancel out. And 2 minus 4 is negative 2. So that's our answer for this one. Next, we've got this very large multiplication problem here. So I'm going to show you the general rule, and then we'll do some specific examples after that. So, if we're going to multiply these, we use the distributive property multiple times. What we do is we take the first term and multiply it by each term in the second one. Now in doing so, we'll use some of that addition of exponents. So I've got 3a squared times a is a cubed. B times b squared is b cubed. Next term. 3 times 7 is 21. A squared times a is a cubed. And b times b is b squared. Next, I'll switch colors here. We've got the second term. And you multiply that by each term. So 2a times ab squared, we get a 2. A times a is a squared. And then we've just got a b squared. Then 2 times 7 is 14. A times a is a squared. And we have a b. Then finally we take the last term and multiply it through to each term. So we get negative 3. There's no a here, so it's just a. And b times b squared is b cubed. And the last term is negative 3 times 7 is negative 21. There's just an a and a b squared. So now what we do is we look and see if anything can combine. And I don't see any way for that to happen, so that's our answer. Nothing seems to have exactly the same powers of every term. So that's all we can do with it. So, here's some slightly easier ways to multiply polynomials. And you've probably run across these things in the past, such as FOIL. FOIL simply means first, outer, inner, last. So let me show you with this example. First, we do x squared times x squared, and we get x to the fourth. Outer, x squared times y is just x squared y. Inner, negative 2y times x squared is negative 2x squared y. And I just rearranged a couple of variables to make this easier to work with. And then last. The last is a negative 2y times y, which is negative 2y squared. Now I can simplify this a little bit. X squared y minus 2x squared y is just negative x squared y. Keep my negative 2y squared, and I'm finished. So that's the FOIL method. It works when you're multiplying two binomials. First, outer, inner, last. So, right here we see a star, and that simply means this is a problem for you to try. So, feel free to pause this video and take a look at this problem and see if you know what to do with it. Okay, now that you've hopefully given this problem a try, let's see how you did on it. First, 3a squared. Outer, negative 6ab. Inner is 4ab. Now I could have written 4ba, but I just switched them so that we had the same looking terms. You can always switch multiplication around. And then finally we get negative 8b squared. So if I simplify this, I get 3a squared minus 2ab minus 8b squared, and we are finished. Hopefully you got that one right. If so, good job. So here's a couple of other techniques. Now these special products come in very handy in different circumstances, but I particularly like the bottom two. The top one is useful sometimes, especially when you're trying to do some simplification that we'll get to later. But the bottom two are techniques that students tend to not use, and it really would save themselves some trouble if they did. So if you square a binomial, you get the first number squared plus twice their product plus the last number squared. And if you treat it like that and the negative sign is part of it, it's the same rule. First number squared plus twice their product, which is negative because this was negative, plus the last number squared. Even if it's negative, squaring it makes it positive. So it's a good technique to keep in mind. First number squared plus twice the product plus the last number squared. So let's use that one. So here, first term squared plus twice the product. Keep in mind one of those was negative. Plus the last term squared. And you can just use 3 because if it were negative 3 or positive 3, the square is still 9. And then we get x squared squared. Remember, power to a power, you multiply the powers. Get x to the fourth. This one comes out to negative 6x squared, and 3 squared is 9. So that's a little bit faster than using FOIL. And you'll notice one thing. The shortcut that a lot of students tend to accidentally do is they'll just square the first term and square the last term. But that's not true. This is a binomial times a binomial. You would have to FOIL it out, and you would get a middle term. So, don't jump too quickly into these techniques that you think work, unless you know that they work. So for these two formulas, they're great tools, but remember, when you square a binomial, you get a trinomial, so you don't accidentally try to use a formula that doesn't work. Alright, problem B has another star beside it, so feel free to pause this video and give this one a try also. Okay, let's see how you did. So we've got the first term squared plus twice the product plus the last term squared. And again, I'm not going to bother with the negative sign. Doesn't matter. I get x squared minus 6xy plus, remember the square applies to the 3 also, so 9y squared. And there you go. So memorizing this formula does save you some time and also help you to avoid errors.